Good evening, children. I wish you a very happy and prosperous New Year 2021, everyone. Be brighty in this New Year, everyone. And yes, let us come back to our mathematics session today. That is, we are in trigonometry, right? Yes. In the last class, we completed the allied angles. Now we will see some problems from trigonometry, which it will covers the exercise 4 and essay type questions we will see today. Okay, children? Yes, we will start that. Write down one question, otherwise we'll see. Okay. Prove that root of 1 plus sine theta by 1 minus sine theta is equal to secant theta plus tan theta. Prove that root of 1 plus sine theta by 1 minus sine theta. Then we have to prove that secant theta plus tan theta or sec theta plus tan theta. Try to pronounce as secant theta. It looks like very fine to call as secant. Okay? Okay, secant theta plus tan theta. We'll prove this one. Take LHS. That LHS is root of 1 plus sine theta by 1 minus sine theta. Root 1 plus sine theta by 1 minus sine theta. How we will do this one? See the simple logical thinking, that is, the root is there here. We have to delete the root. But we can't do that squaring on both the sides because there is no RHS. There is no RHS. Only this is the expression. LHS is there. For that, the rationalization is there. Akarniya karna. Akarniya. Rationalization is there. So we have to do the rationalization. What is the denominator we have? 1 minus sine theta. We have to reduce this one into a square minus b square form. So here already a minus b is there. We want a plus b expression. A minus b. Think this one is a minus b. Then we want a plus b. Nothing but 1 plus sine theta. We have to multiply numerator as well as denominator like this. That is root of 1 plus sine theta by 1 minus sine theta. Here you have to do the rationalization. You have to take numerator and also denominator. What is here? A minus b, na? Then a plus b we have to take. A plus b. Both we have to take, both are absolutely equal. You should have to take both are absolutely equal because we can get cancel these two. There will not be any new terms we multiplied. Same as it is. A minus b, nothing but a plus b. We have to do the rationalization. Now see that. See the denominator, a minus b into a plus b. A minus b into a plus b. We have a formula of a minus b into a plus b is a square minus b square. A square minus b square. That is nothing but 1 square minus sine square theta. 1 whole square. Nothing but how much? 1 square minus sine theta whole square. 1 square minus sine theta whole square. 1 square values never change. 1 itself. That's what I written. 1 minus sine square theta. Highest. Here a plus b into a plus b. Both are same. Nothing but what you will get here? A plus b whole square. 2 times is there. See? A plus b into a plus b. A plus b whole square. You have to write, you have to reduce in the form of a plus b whole square. 2 times are there as it is. As it is, 2 times are there here. So a plus b whole square. Now we can do something, that is, yes, 1 plus sine theta whole square. We have an identity. We have a 3 identities, right? We have a 3 identities. The first identity, okay, let's write here the first identity. We write the identities. We have 3 identities from the trigonometry, that is sine square theta plus cos square theta is equals to what? Identity is nothing but 1. We have some relations, some identities we have. Sine square theta plus cos square theta is equal to 1. This is first identity. Second identity is secant square theta minus tan square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. Then third one is cosecant square theta minus cot square theta is equals to 1. These are the 3 identities we have. 3 identities. Sine square theta plus cos square theta is equals to 1. Next, secant square theta minus tan square theta is equals to 1. The final one is cosecant square theta minus cot square theta is equals to 1. With the help of this one, you can do something. See here, a square minus b square, nothing but 1 minus sine square theta. Na? See, from this first identity, minus plus sine square theta sent to this side, it becomes minus. What is the result? Cos square theta. Cos square theta is equal to, you can write as 1 minus sine square theta. 1 minus sine square theta. Means 1 minus sine square theta you can write as cos square theta. Here you can write cos square theta from the identity, from this identity. From this identity, we can write 1 minus sine square theta as cos square theta. 1 minus sine square theta you can write as cos square theta. These are the 3 identities, the most important identities from the trigonometry chapter. Sine square theta plus cos square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. Cosecant square theta minus cot square theta is equals to 1. So from the first identity we done this. Now what happens? See, square and the root get cancelled in numerator. Square and root. So what you left here? Sine theta is left. 1 plus sine theta is left. In the denominator also, square root and the root square get cancelled. Square root and square deleted. This is deleted. Here deleted. So you will get here what? Cos theta. You will get here what? Cos theta. Squares get cancelled with root. Squares are get cancelled with root. The left is only which you have this one. That is 1 plus sine theta by cos theta. 1 plus sine theta by cos theta. Now what is here? See what the next? Yes, okay, I will adjust here. I will adjust here. Now you can see in the numerator we have 2 terms. Numerator we have 2 terms. Denominator we have only 1. So split it that one. Split it as like this. 1 by cos theta. Split it. 1 by cos theta plus sine theta by cos theta. Sine theta by cos. The denominator I split it into 2 terms. 1 by cos theta plus sine by cos theta. Now, see, already we know, the very first class I said, reciprocal of 1 by cos theta. Reciprocal of cos theta. What is 1 cos theta reciprocal? Secant theta. Secant theta or sec theta plus sine by cos you can write as tan theta. Sine by cos you can write as tan theta. 1 by cos is secant, sine by cos is tan. What we want here? The same is, that is RHS. Therefore, LHS equal to RHS. Hence proved. You have to write this label. Hence proved. So LHS equal to RHS. Hence proved. Once again, take the LHS part, that is root of 1 plus sine theta by 1 minus sine theta. You have to do the rationalization with the 1 plus sine theta. Because my minus is there, you have to do the rationalization 1 plus sine theta by 1 plus sine theta. The 1 plus sin theta into 1 plus sin theta both are equal. Two terms are absolutely equal. You can write as 1 plus sin theta whole square, totally whole square. And this is numerator denominator. Certainly, whenever you will do the rationalization, you will get in the form of a square minus b square to delete the root. To delete the root. So a minus b to a plus b is a square minus b square. 1 square is 1, sine square is sine square theta. And 1 minus sine square theta just I written as cos square theta because from this identity. Sine square theta set to this side, it becomes 1 minus sine square theta. Nothing but you can write as cos square theta. See, here the square and the square will square root get cancelled. Deleted. The left is 1 plus sine theta by cos theta. In the numerator, you have two terms split into two terms, that is denominator 1 by cos theta plus sine theta by cos theta. 1 by cos you can write as secant, sine by cos you can write as tan theta, which we want that is as same. And this is one of the most important. And here sometimes he will give 1 plus cos theta by 1 minus cos theta also he will give. So that here you will get here cosecant theta plus cot theta you will get. Okay, right, fine, whatever it is, you will see in the end of this session. I will do some 1-2 problems as homework. At that time, I will change this question. Okay, fine. This is, if you want to take the screenshot also with that identity. Now we'll go with the one more important 4-mark problem. Okay, children? Yes. These identities are most important here. Right. Prove that, okay, not prove that, find if secant theta plus tan theta is equal to P, secant theta plus tan theta is equal to P, then find sin theta in terms of P. In terms of P. If secant theta plus tan theta is equal to P, then find sin theta in terms of P. Then find sin theta in terms of P. The value of sin theta you have to show only in P. You should not see the other ratios, which is most important. This is the result of sine you have to show only in P or any constant. You have to delete the ratios. You have to delete the ratios. How? We will see now. Right? What he given? Secant theta here. Given sec plus tan is equal to P. We have identity of secant. Just I erased. What is the second identity? Secant square theta. Since secant square theta minus tan square theta is equal to 1. Second identity. This is second identity. Secant square theta minus tan square theta is equals to 1. Now we can write a square minus b square formula. See, a square minus b square. What is a square minus b square? Just we completed a plus b into a minus b. A plus b into a minus b. That is a plus b into a minus b. A plus b, a minus b is a square minus b square. Already we know secant theta plus tan theta given. What is given? Secant theta plus tan theta is what? P. Secant theta plus tan theta is P into secant theta minus tan theta is equal to what? Now here Secant theta minus tan theta, find out. Secant theta minus tan theta is equal to what? P sent to this side. It will go to denominator because this is in product. Since this is in product, so that secant theta minus tan theta is equal to 1 by P. 1 by P. This is the, you got it already. Secant plus tan is equal to is there. Here secant minus tan. Let us take this is first equation. Let us take this is second equation. Okay, children. Secant theta minus tan theta is equal to 1 by P. Now add first equation and the second equation. We get what we will get. Let us see. Yes, secant theta plus tan theta is equals to P. Secant theta minus tan theta is equals to 1 by P. Add these to add. So see, plus tan minus tan get cancelled. Plus tan theta minus tan theta 0 or cancel. Secant plus secant. Secant theta plus secant theta is 2 secant theta. 2 secant theta is equal to P plus 1 by P. See, we can't add these two. P plus P, 2P, no. Here P is there, here 1 by P is there. So P plus 1 by P. P plus 1 by P. 2 secant theta is equal. Now next is, now secant theta value what? What is secant theta? Secant theta is equals to 2 sent to this side. Okay, first do the LCM. What is the LCM, Nana? P is the LCM. P is the LCM. How many times going? P times going. So P into P, P square. P into P, P into P, P square plus 1. P into P. The LCM is P. Once again, 2, this is you got it. Secant theta we will find. Okay. First take the LCM. What is the LCM of this one? P is the LCM. Now P into P, P square plus 1. Here 2 is there, na? Send it to this side. It becomes here 2P. It becomes here 2P. You got it, secant value. The reciprocal of secant is there. The reciprocal of secant is, what is the reciprocal of secant? Cos theta. Yes, cos theta is equal to reciprocal, na? Here also you have to do reciprocal. So you will get here 2P by P square plus 1. P square plus 1 by 2P, na? You will get reverse. Reciprocal you will get. That is 2P by P square plus 1. 2P by P square plus 1. Now we can find the value of what we have to find. What we have to find? Sin theta. We can find now sin theta. We have identity 1. What is identity 1? Sin square theta plus cos square theta is equals to 1. Sin square theta plus cos square theta is equals to 1. Then sin theta is equal to root of 1 minus cos square theta. Because we know cos value. Substitute cos value here. 1 minus 2P by P square plus 1. Cos value 2P by P square plus 1. Cos value. I replace the cos value. Square is there, I written square. Now expand that. Whole square, do that. So you will get 1 minus 4P square by, don't expand, keep like this. 2P whole square is 4P square. 2 2s are 4, P into P square. Be like this, keep it like this. P square plus 1 whole square. P square plus 1 whole square. P square plus 1 whole square. Now take the LCM of this. What is the LCM? P square plus 1 whole square is the LCM. P square plus 1 whole square is the LCM. Now how many times going here? As it is, because 1 na, the denominator also 1. So what will be the LCM? The same you will get here. So what is the LCM here? P square plus 1. Here also you will get P square plus 1 whole square minus 4p square minus 4p square. Okay, here the LCM is p square plus 1 whole square. Here also you will get same as it is, you will get p square plus 1 whole square minus 4p square minus 4p square. Yes, here one more. You see, this is we have a formula. Okay. A plus p, we have a formula. A plus p whole square minus 4ab formula. A plus b whole square minus 4ab formula is a minus b whole square. This is the formula. A minus b whole square formula. This is a plus b whole square minus 4ab. B value is 1. B value is 1. So 1 into same you will get. That's what you can't see that. A plus b whole square minus 4ab formula is a minus b whole square. A minus b. This is the formula here. So now you can write the next step as with root. A minus b whole square. A minus b whole square. Denominator is same. That is p square plus 1 whole square. P square plus 1 whole square. Numerator I reduced like this. A plus b whole square minus 4ab. Here I didn't form a minus b whole square. So p square minus 1 whole square. P square minus 1 whole square. So what you will get? See now, square. Here the square is get cancelled, not this one. This square will get cancelled because brackets is there. Brackets square will get cancelled. This is square, not this is square. That is in terms. You should not get cancelled. Whole square is there. Whole square will get cancelled. So the result you will get here p square minus 1 by p square plus 1. Square root get cancelled. These two square and root get cancelled. So you got it, that is p square minus 1 by p square plus 1. So finally you got it, p square minus 1 by p square plus 1. What we have to find? Find sine theta in terms of p. Find sine theta in terms of p. See, this is the sine theta. This is the sine theta in terms of p. P only there here. Constant is the p is there. There is no cos theta. There is no secant theta. There is no tan theta. Only in terms of p. P is the constant is there. Let be the constant. Nothing will happen. But you should not show with the ratio. Sine, cos, secant, tan. You should not see these all. See, that is nothing is there. Only p is there. This is most important. And 4 mark compulsory question. I hope this is the 4th exercise, last problem. 4th exercise, last problem from trigonometry. 11.4. 11.4. Yes. Once again we will see. See, observe very carefully while teaching this one. Given secant theta plus tan theta is equal to p. We have an identity. The identity is a square minus b square, which is secant square theta minus tan square theta is equal to 1. Second identity this is. Second identity. Secant square theta minus tan square theta is equal to 1. This is in the form of a square minus b square. A square minus b square. A plus b into a minus b is the formula. A plus b into a minus b. See, I written secant theta plus tan theta, secant theta minus tan theta. We have this value already given. What is this value? P. So write down here p. If you want, take brackets. P. And as it is, there is no change. Secant theta minus b. Because we know this one. We written p. 1. So p side to this side becomes 1 by p. It will goes to denominator because into. This is an into, so it will goes to denominator while sending from one side to other side. Yes, so let us take this is second equation. What he given, let us take that is the first equation. Add the two equations that we get. Secant theta plus tan theta is equals to p. Secant theta minus tan theta is equals to 1 by p. While adding, plus tan minus tan get cancelled. Plus tan minus tan get cancelled. And the left is secant plus secant is 2 secant theta. Secant plus secant is 2 secant theta. And p plus 1 by p. Take here LCM. What is LCM here? P is the LCM. P into p, p square. Plus 1 by p into p, p square plus 1 by p na, but here 2 is there. Send it to right side, it will go to denominator. It will go to denominator. You got it secant theta. You got it secant theta. But what is the reciprocal of secant theta? Cos theta. This is cos theta. You got it, cos theta is equal to reciprocal you have to do. Reverse you have to do. P square plus 1 by 2p na, you will get 2p by p square plus 1. Reverse you will get. So this is therefore. You got it cos theta. Now what we have to find? What we have to find? Sine. We have a first identity. What is the first identity? Sin square theta plus cos square theta is equal to 1. First identity. From that, what is the value of sine? Sine is equal to root of 1 minus cos square. Why I took this one? Because I know the value of cos. Because cos value given. Already you got it. Cos value substitute in this. I substituted. See, cos value substituted. That is 2p by p square plus 1 whole square. Whole square. Expand that. Expand it. So 2p whole square nothing but 4p square. 2 2s are 4. P into p square. And p square plus 1 whole square as it is I written. P square plus 1 whole square. Don't expand because it is very easy to do this one like that. So p square plus 1 whole square. Now the LCM is p square plus 1 whole square. As same you will get. P square plus 1 whole square. Because there is no denominator. Nothing but 1 is the denominator na? Same as it is. What is the LCM? The same you will get here. The multiple. So p square plus 1 whole square. Because 1 into this one as it is. P square plus 1 whole square minus 4p square. Minus 4p square. I written the formula a plus b whole square minus 4ab is a minus b whole square. What is a? P square. What is b? 1. So write down here a minus b whole square. Denominator already p square plus 1 is there. Denominator already p square plus 1 is there. So square root to square root get cancelled. Square, whole square, not this square. It's wrong if you do this one. Whole square will get cancelled, not in terms. Not in terms. This is in terms. This is in terms. It will not get cancelled. Because whole square is there, that one will get cancelled. These two will get cancelled. The remaining is p square plus 1 by p square plus 1. P square minus 1 by p square plus 1. P square minus 1 by p square plus 1, which we got it in terms of p. This is only in p. There is no sin theta. There is no cos theta. There is no secant theta. There is no tan. Other ratios, it's not there. Only p is there, constant is there. So we have to show that in terms of p. That is in terms of p. Therefore, sin theta is equal to p square minus 1 by p square plus 1. P square minus 1 by p square plus 1. This is one of the most important compulsory 4-mark question from the trigonometric chapter we have. Okay, children. Once again, if you want, take the screenshot of this one. And we will see the last and the final problem of today's class. Take a screenshot. We'll see the one more problem, that is simplify or find simplify 1 minus cos theta into 1 plus cos theta into 1 plus cot square theta. Simplify. Just calculate. 1 minus cos theta, 1 plus cos theta. This is most important one. As 1 mark question. Yes. Again write down. 1 minus. Question you have to write again in the solution. 1 minus cos theta, 1 plus cos theta, and 1 plus cot square theta. Yes. See, a minus b into a plus b. 1 minus cos theta into 1 plus cos theta, you can write as 1 minus cos square theta, a square minus b square. A square minus b square. A square minus B square. And there is, see, 1 plus cot square theta you can write as cosecant square theta. We have a third identity. We have a third identity. What is the third identity? I will write here. That is cosecant square theta minus cot square theta is equals to 1. This is the third identity. We have a first identity sin square theta plus cos square theta is equals to 1. Second identity is secant square theta minus tan square theta is equals to 1. The third identity is cosecant square theta minus cot square theta is equals to 1. Third identity. Yes. Now see, minus cot square bring to this side, minus cot bring to this side. What happens? 1 plus cot square. 1 plus cot square, which is cosecant. 1 plus cot square you can write as cosecant. I have written this one as like this because send it to this side, it becomes 1 plus cot square. 1 plus cot square you can write as cosecant. I written here. And this is a minus b into a plus b is a square minus b square. See, again you got it first identity. 1 minus cos square theta you can write as what? Sin square theta you can write. Sin square theta you can write. Formula, first identity. And cosecant, what is the reciprocal of cosecant? 1 by sin square theta. Here cosecant square is there, na? So you got it here sin square. So you can write this one as 1 by sin square theta. You can write this one as 1 by sin square theta. So these two will get cancelled because in into these two you can get cancelled and remaining is 1. Simplification, calculation, find otherwise. This is so already we covered 3 identities. The first identity in the first problem, second identity in the second problem, third identity in the third problem. These are the most important. And see, this is 1 minus cos theta into 1 plus cos theta, 1 plus cot square theta. You can write this one as a minus b into a plus b is a square minus b square. A square nothing but 1 square is 1. There is no change. 1 minus cos theta. 1 minus cos theta you can write as sin square theta. First identity. And 1 plus cot square is the 1 plus this one. Send it to this side, it becomes cosecant square, which is third identity. We have a third identity. You can write this totally as cosecant square theta. Reciprocal of cosecant square theta 1 by sin square theta. And these two will get cancelled. The remaining is only 1. If this is 1 indirectly, 1 into 1 is 1. 1 into 1 is 1. So these are the 3 formulas, identities. With the help of these 4 identities, we done some problems, isn't it? And I will give now 3 problems as homework with the includes of these identities. With the help of these identities, we have to do. Okay, children. Now take the notes and write down the 3 questions as homework. That is, first one. Prove that root of 1 plus cos theta by 1 minus cos theta is equal to cosecant theta plus cot theta. Cosecant theta plus cot theta. First one, prove that. Second one, if cosecant theta plus cot theta is equal to k, cosecant theta plus cot theta is equal to k, then find cos theta in terms of k. In terms of k. And third question, like this, simplify 1 minus sin theta into 1 plus sin theta into 1 plus tan square theta. 1 minus sin theta into 1 plus sin theta into 1 plus tan square theta. Simplify. This is using first identity. This is a using of second identity. Both you will get. In this also third identity. These are the three questions already we completed just before. Related to that, if you will have any doubts, you will get the YouTube link of the same session. You can see that multiple times. If you will have any doubts, you can raise. You can clarify your doubts. Okay, children. So we will wind up today's class. Within a short of 2-3 minutes, the Telugu session, Telugu class will going to start. Thank you.